Next class, when I do come up for y'all, I'm going to check homework. So you need to have, if I haven't checked your 6.1 and 6.2, I'll be looking at it then. I'm also looking at 6.3, which is on the blue sheet. I think it's, 7 problems? How many is it? 7. 7 problems. And then I will be looking at this homework, which is at the end of the packet. And it's only 4 problems, okay? So homework check, academic lunch will be assigned if you do not have it done. When I am coming around checking, you are probably going to have homework because both of these lessons just kind of take a while. So make sure you have that done. And then it will be review time. Again, all these will be on Canvas, the keys to the CFUs, which you've kind of already graded, but they'll be there. And then answers only for the practice and the review. I will leave a good review key with all the work for you to check. So that's happening Wednesday. Friday is your test. It is 3 grades. This has a potential to really help your grade a lot. But if you just blow this off, it's really going to hurt your grade because the test topics, there are 3. There's only 3 to 5 problems in each section, which means they're around 20 to 30 points each. So small mistakes will add up quite a bit. So just fair warning. Okay, the topics, especially topic 1, is not super hard. Grab one of those. Anyways, so just be mindful of that while some of these topics are really very easy, add, subtract, multiply is easy, but you really need to go back, look through your notes, because pretty much everything we did on the notes is fair game for the test. Look through the review, look through your practice problems. You can look at those again. Those are all good indicators. Division has got 2 lessons over it. And then today's lesson is its own test topic as well. So today's lesson is important. Even though we're at the tail end of kind of what we're learning in this, I would not suggest that you just blow off today and decide to take a free day because I'm not going to teach this to you in tutorials. Okay? You're learning it now. And so that's what's going on there. Okay? So everyone is clear. Everyone is clear. What to do on the test day? The review. Okay? And then after the test, we will focus on getting ready for retest. We have a little bit of stuff to learn, but we'll spend that time, I might do some warm-ups for retest purposes and things like that because the lessons that we're learning aren't super crazy, but they're important. So you need a calculator if you don't have one because we are going to talk about how to do polynomial inequalities with the calculator as well. So first thing, real quick, is I want you just to answer these questions that are not in bold, under graphically, and under algebraically, okay? So for instance, if y is greater than or equal to 0, where are the values located? So on a graph, if I ask you, where are the y values greater than or equal to 0, where would you say? Above the x-axis and on the x-axis, because it says or equal to. What if it just says y is greater than 0? That's just above. Okay? Y is less than or equal to 0. What am I going to circle? Below. And y is just less than 0. I'm going to circle below. Okay? There's some steps on how to solve graphically. We'll talk about that in a second. Algebraically, if y is greater than or equal to 0, can you equal 0? Yes. Yes? Will the values be positive or negative? Positive. Because greater than 0 is positives. Y is greater than 0. Can they be equal to 0? No. Are they positive or negative? Positive. Y is less than or equal to 0. Can you equal 0? Yes. Positive or negative? Negative. Y is less than 0. Can they equal 0? Nope. Positive or negative? Negative. Okay. So what we're looking at today is polynomial inequalities. It's kind of a blend of some stuff we have done over the past few units. But what your problems look like, you can kind of look at them here, is you're solving not equations. So this first page, especially since they're quadratics, is kind of a flashback to Unit 5 when we talked about quadratic graphs. And you're not finding where they're equal to 0. You're finding where they're greater than or equal to 0, less than, one of those there. But we also are going to extend it to polynomials, so you're going to have some higher degree stuff that we're dealing with. So each problem that we're going to go through is a little bit different here. But ultimately, it's not very hard what we're doing. The algebraic method does require a little bit of work because we have to fill out a table thing, but it's just really not that bad. So let's knock it out, and then you can get, hopefully, at least a few homework problems done. I am going to work the first problem graphically. Thank you. I'm going to work the first problem on the notes graphically because that's what it's going to say to do. So we're going to do problem number 1 by graphing. So let me just kind of walk you through the steps. The steps in solving graphically versus algebraically are a little bit different, but they're kind of the same because you need to have your inequality, I'm going to say air quotes, equal to 0, because it won't be an equals. It'll be one of your inequality symbols, but you want your polynomial, most likely in standard form, on the left-hand side, and then you want 0 on the right-hand side. So that's the first step for both algebraic and graphic. But you need to make sure when you do this, you're looking for the roots. So finding the roots in the calculator is going to be a little bit different than how we find roots algebraically. But then ultimately we're looking at, okay, where is this graph above or below the x-axis or on, depending on the symbol. So here's how you do it graphically, and I'm going to circle this because, again, I do believe you're going to have an option to solve something graphically on your test if you choose to. Majority of the time I will ask you to do it algebraically, but this is an option, like sole option if you, and I want to show you what work I'm expecting, but even if you do it algebraically, you can still check working graphically, okay? So here we go. Example number 1. Is my inequality, my left-hand side, quote, equal to 0?
Yes.
Yes, okay? Now, if you're working graphically, you don't really care about the fact that this is negative. If I was doing this algebraically, that would drive me crazy. How could I get rid of it if I wanted to do it algebraically? Multiply or divide by -1. But what happens in inequality land if you do that? The sign flips. So just be careful of that. There's a homework. We're not doing that here, but there is a homework problem that we are going to do that. So I just thought it would be worth mentioning. But since I have a calculator, I don't really care. So I'm going to put this quadratic equation in my calculator in Y1. Go ahead and clear your calculator real quick. How do you do that? 2 plus 7, 1, 2. Okay, so I'm going to put in Y1 negative 2x squared plus 7x plus 4. Okay. And let's talk about this sign right here. This sign says the quadratic needs to be what? What symbol is right there? Greater than or equal to 0. So what am I looking for? What type of y values if it's greater than or equal to 0? Positive. Can you equal 0? So positive or equal to 0. And now I'm going to be graphing these on a number line. We haven't done number line stuff in quite some time, but if you have an or equal to symbol, what kind of circles are you going to put on your number line?
Close.
Close. Very good. So I just kind of want to write those notes like this is where I'm looking. I want to know where I'm positive or equal to 0. I'm going to be using closed circles, but ultimately what I need to find is I need to find the roots. So here's how you can show work for me, okay? When you're finding roots in a calculator, let's go ahead and hit graph and see what it looks like. And this will be a quadratic because it's x squared, so I'm going to see a parabola, okay? I can't see the total max here, but I'm not going to switch stuff around. I don't really need that. I'm looking more at the roots. I'm looking at the concavity. But my picture is asking me, okay, where is this graph greater than or equal to 0? Now, I don't want to just guesstimate from here. I want to go actually find what the roots are, and I want you to, how you show work, if you do it graphically, I need to see what your actual roots are, and then we're going to sketch a picture, okay? So, review from Unit 5, how do you find the roots in your calculator? What has to be in Y2? 0, very good, because you're looking for when it intersects with 0, and then you are correct. You go to second trace, you choose 5. There are 2, so scroll near one of them, and you press enter 3 times. Enter, enter, enter. So one of my roots is at negative 0.5. And then I start again. Second trace 5. Go to the other one. Enter, enter, enter. So as far as showing me your work, and these don't have to be pretty numbers. It's great when they are. When you're doing it algebraically, they probably will be pretty numbers, but technically they can really be whatever. And now I'm going to draw a picture. Now on your picture, I don't need you to get caught up. Really, I just want to see the correct roots and the correct concavity. I wouldn't worry too much about the y's. I don't want that to stress you. But I do want to see that your roots are kind of in the right spot. 2, 3, 4. So I have a root at positive 4. I have a root at negative 0.5. And my graph is concave down. So I can see that the graph looks something sort of like this. So as far as solving graphically, this is about the work. I'm trusting you know how to get these in your calculator. But this does work for me there. Okay? And then my question is, where is my graph, where is this parabola greater than or equal to 0? So when I look at my picture, I want you to either highlight. If you don't have a highlighter, I'll show you how you can kind of shade with a pen or something. But I want you to label on your graph where the graph is greater than or equal to 0. It's not hard. It's just where is it positive. So if I read the graph left to right, y'all watch my finger. Am I positive right here?
No.
Am I positive right here?
No. Yes.
Positive until
There.
and then I'm looking at this region. This is the solution set that I'm looking for. Okay? If you don't have a highlighter, you can just do this. Kind of color it. That works for me too. Here's my region where it's positive. So this is my solution set here. My solutions. Now there is only one interval. I only highlighted or shaded one little area because it was just between the roots. I do want you to put this on a number line. Okay, so what that would look like is, I'm going to kind of pick in the middle. I'll put this as 0. I think I'm going to count by 0.5s so that way things are kind of pretty. So I actually am going to label. So this will be like -1, -2, -3, -4. 1, 2, 3, 4. You don't have to, but just to make my graph a little bit easier. And I'm going to put at those roots, -0.5, I'm going to put a closed circle here above -0.5 and a closed circle above +4. Why is it a closed circle again? Because it's less than or equal to 0. And so how do I represent, okay, this is my solution set. How do I represent that on a number line?
Draw a line in between.
I just connect them. I connect them like this because it's all those x values between here and here. It's almost like your graph makes its own little number line right there. And so that would be my graph. In this section, you are going to see number lines that you do have to graph. And then it will also ask you for your solution set. And that will be like a blank. And I would like you to write what interval you just graphed. There is only one because there's just one thing on the number line, one part of my graph that's above. And so I would write that. You have two options. I will write both options on my notes. You don't have to write both notations. You can pick your favorite. I think what most people will do is the inequality. -0.5 less than or equal to x less than or equal to 4. Again, the equal to's are because the original problem was equal to. That's going to kind of stay like that. That's one way. That's inequality notation. That's where I feel like most people will do. The other way that you could write it, I'll say or, is interval notation, and that looks like this. Square bracket, -5 to +4 with a square bracket. Why is it a square bracket? Because it's equal to. So again, it's this guy, or you can write it this way. You do not have to write both. Just know on my answer keys, I kind of put both. There's always someone that likes to do interval notation. I tend to lean towards that, but That is your answer. So this is sufficient work if you do something graphically. What are your roots? Sketch me an accurate picture. Tell me what you're looking at. Put it on the number line. Put it on inequality. Okay? You're not going to be able to do this on all the problems, but if it says you can do either, this is the appropriate work to be shown. Do we understand? Okay? Algebraically, this is going to be the way that I ask you to do it most of the time, is solving algebraically. So we're going to do the rest of it this way. Ultimately, we're doing the same couple steps. We're getting our equation equal to 0. Again, air quote. We are figuring out what the roots are. Now, if you look, you don't have to look, just look at mine. If you look at the steps, it kind of says there's a couple ways that you can find the roots. Majority of the time, we're going to be able to factor. But the good old quadratic formula is how you can get roots of a quadratic. Higher degree polynomials, which we'll see, we might need to do some synthetic division and then continue to factor from there. But we're trying to get the roots. And then we're going to put them on the number line, and then we're going to have to do this little sign chart thing that's going to take some space, but it doesn't take that much brain power. So just don't whine about it. I'm telling you, my last class is whining about it, and I'm not in the mood. Okay? So example number 2. Are you with me? The next couple problems are going to take a big chunk of time just because it's kind of a lot to walk through. All right, what do I have to do very first thing? Move it. So this will be x squared minus 2x minus 15 greater than or equal to 0. Now, if I'm doing something algebraically, if the front guy is negative, I would absolutely recommend dividing by a negative, but you do have to flip the inequality. We're positive here, so we're good. Is this going to be factorable? Yeah, let's. And is it easy factoring? How do you know it's easy factoring? Because the a value is 1, factoring. Okay, so when I do that, I'm going to number puzzle it. What goes at the top of my number puzzle? Negative 15. Oops, negative 15. What goes at the bottom? Negative 2. And so what are those two numbers? Negative 5, positive 3. So that would mean that my factors are x minus 5, x plus 3. But from there, I need my roots. So what are my roots? X equals 5 and x equals negative 3. That's a big part of what I'm looking for. I'm going to circle that. But then I'm also going to go and I'm going to write my standard form. I'm going to write it in factored form. X minus 5 times x plus 3 is greater than or equal to 0. Okay, so essentially, I know that my original standard form and my factored form are the same. How can you check that?
Plug it in.
Plug it in how? Standard form in y1, factored form in y2, it's minus 5 plus 3, right?
Yeah.
Right? Yeah. Second graph, are the tables the same? So that's kind of a spot check to make sure that you're good. Okay, so we're good. I also like to kind of box this sign right here, and just like I did above, make some mental notes. I want to know where this polynomial is going to be greater than or equal to 0. So what kind of numbers would make it greater than or equal to 0? Positive numbers. And what kind of, or equal to 0. And what kind of circles would I put on my number line because it's or equal to? Closed. So those are just kind of some notes that I make. And I'm also going to draw an arrow down here for when we get to the sign chart, because I need to focus on that in a minute. Okay? So I moved the equation over, found the roots. I found them by factoring. I made note of what I'm looking for. I'm looking for positives or I'm looking for negatives. I'm going to put open or closed circles. We okay? So now I'm going to put these two roots on the number line. And I always kind of like to put 0 on there just so I can have a basis of where I am. But my roots are at 1 to negative 3, closed circle. And 1, 2, 3, 4, 5, positive 5, closed circle. Okay? Now, we're not doing this graphically. We can go check it graphically later. We're going to do this algebraically. So what I need to look for is, okay, there's basically 3 spaces on this number line that my graph could be. It could be true over here to the left of -3. I'm going to call that area A. It could be true in between my two roots. I'm going to call that B. Or it could be true when x is greater than 5, and I'm going to call that C. So I got to figure out, okay, where's my number line going to be happening? Where am I going to be graphing? Between these, outside these, this one and this one. When we get into polynomials, they can be kind of crazy. Quadratics, they're either together or they're apart with quadratics. But I have to figure that out. And to do that, I'm going to do this little sign chart where it says test interval and test number. This is the only time I'm going to write this in for you. This is part of the reason why these problems take a little bit, because you're going to have to make your own chart. So let me explain it. There's 3 parts in the number line. I called them A, B, and C. Now, the first thing that I want you to do is I want you to write an inequality that represents any point in area A. So that is left of -3. So those are numbers that are less than or equal to -3. That's how I'd write that as an inequality. Does that make sense? This way forever? So how would I write an inequality for area B? To 5. Between -3 and +5. And because my original problem says or equal to, I'm going to continue on with the or equal to. So that's just kind of depends on the original guy. But so this inequality represents, okay, numbers between -3 and 5. And then what's my last one? Numbers that are what? Greater than or equal to 5. So this is strictly just labeling based off of a number line. I'm not really doing anything crazy here. So when it says test number is I'm going to do math without having to actually do like arithmetic, okay? I'm going to figure out if I picked a number in this interval and I plugged it into this inequality, all I really need to know is where am I going to get positive values? So I'm looking at the signs based on my 2 factors, okay? So my factors in this are x minus 5. I want you to write x minus 5 in this first factor column. And then I want you to write x plus 3 in the second factor column. And then we're going to pick some test numbers over here. Okay? So let's talk about A. I want to show you how to work A, and I think you're going to see how this works. It's really not that bad. X is less than or equal to 3. What is a number less than or equal to -3? -4. That works. So if I plugged in -4 to this factor, and you need to label your factors so you know what I'm doing. Cool. X equals -4. -4 minus 5. I don't need to know what specifically that number is. I just need to know what kind of number is it.
Positive.
-4 minus 5?
That's not it.
That's going to be a negative number.
Sorry.
It's okay. -4 plus 3, what kind of number is that going to be? Negative. So if I multiplied these two, negative times a negative, what kind of number would I get?
Positive.
I would get a positive. Now, go back to this little arrow that I drew here. What kind of numbers are we looking for?
Positive.
So is this interval going to be right?
Yes.
So I'm going to highlight that, and I'm going to highlight that. So that's part of my answer. Let's check area B. What's a number between -3 and +5?
0.
I would always test 0 when you can. The only time I wouldn't test 0 is if 0 was an actual root. I don't ever suggest testing the actual roots. Yeah.
Like for number 8, if you did the test number as -3, when it comes to the second factor box, it'd be 0, so it'd be positive or negative.
That's why I wouldn't test the roots. So test numbers outside of the roots. Okay. All right. So 0 minus 5 is what kind of number? A negative. 0 plus 3 is a negative times a positive will give me a. Do we want negatives?
No.
So B we don't care about. B is not right. C, what are we going to test? 6. 6 minus 5 is a?
Positive.
6 plus 3 is a? Positive times a positive is a? Do we want that? So how many intervals are in my solution? 2. So first thing I'm going to do is actually graph these on my number line. So I'm graphing area A, which goes from this guy on forever. Area C goes from this guy on forever. So that's got to match. And then your test is also going to ask for a solution set. And now I just need to write in these two inequalities, which were x is less than or equal to negative 3. Can you stop? Or x is greater than or equal to 5. And this would be my algebraic expression for it. If you're an interval notation person, here you go. Negative infinity to negative 3. 5 to, I don't know. There's always someone who does it, dang it. Okay? And then you can check it graphically, but I'm telling you, if I say to solve it algebraically, which majority of the time I will, this is what I'm looking for. Yeah, because I didn't draw the sign chart for the other ones. So yeah, we started complaining. We complain about a lot of things. It's very annoying when people complain. Or this is annoying? The lesson? Oh, I'm sorry. Well, you can think it's annoying. That's okay. It just is what it is. You have to do it. So, you know. We are. But here's the thing is the next little section. So I think this is why they started complaining. We're going to have more roots on the next couple problems. So we actually have 4 places. Yeah. They complain a lot. Algebraically, yeah. Which is majority of the time. Okay? All right, let's flip over. 3 and 4 are excellent problems to know how to do. You can check with calculator. Absolutely. I would do that. And then this last graph, did I already have it in there? Yeah, I think I already had it in here. So this last graph would look like, it's going to graph 2 because I have the factored form. But again, you can check. You're looking, okay, I want to know where I'm greater than 0. And my greater than 0 are these 2 branches, which is why there's 2. So quadratics, they'll either be going this way or they'll be connecting. But what we're about to do, and I'll draw that. I'll sketch this graph right here for you. What this graph looked like was you had your roots. It was concave up. So this was your right here and right here. Okay? And that's why there's 2. But when we start graphing polynomials, now we don't teach actually graphing polynomials. So we're going to have to do these algebraically. But I can show you how to kind of analyze it in the calculator. But just know that anything that's higher than degree 2, like graphing-wise, is going to be a little crazy. Okay? And you'll do that more in pre-cal. So this is something you are going to see in pre-cal again. But let's look at example 3. Okay? Solve x minus 3, x plus 4 squared, x plus 7 less than 0 algebraically. Okay? Are we equal to 0? Yes. Quote unquote. Yeah.
No,
Yeah, we are. Well, that's why I'm saying air quotes, because it won't actually be equal. But is 0 by itself?
Yes.
Is it function, symbol, 0?
Yeah.
Okay? All right. What does the symbol mean? What kind of numbers are we looking for?
Less than.
Negatives. That means we're looking for negative numbers. What kind of circles are we going to have on our number line? Open. Make a note of that. And then I would even kind of draw that down here because I'm going to make a chart down there. So I'm looking for where it's negative. Now, here's the good thing about this. There's a good and a bad. The good thing is that, do you have to factor this problem? No, it's already factored for you. Good thing. Bad thing is, how many roots do you actually have? 3. The degree is 4, but there's only 3 roots. So what are they? Let's just go in order from left to right. X equals?
3. Negative 4.
X equals negative 4, and x equals? Negative 7. Now, I know that x plus 4 has a squared. Shush. But it's still going to give you the same number. The squared does affect the graph, and you're going to see it in just a second with what it looks like. Okay? So I'm always looking for the roots. Now I need to put these roots on the number line. So pick wherever you're going to put your 0. And then go put open circles above those roots. 1, 2, 3, 4, 5, 6, 7. Open circle, open circle. 1, 2, 3. Open circle there. Okay? So, the more roots that you have, the more, can we please stop with the noises? The more roots that you have, the more areas you're going to have to check. Which means that, and we're not going to do more than 3. But it is kind of a hassle to go through and do all 4 of them. So, this is how it's going to look on your test. You're going to have space. It will ask for the solutions. I'm actually going to squeeze the solutions up here. Just FYI. But you are going to have to be responsible for making your own little sign chart. Boo-hoo. Get over it. A, B, C, D. You're not going to have 12 of these. Like, we're talking 3. Okay? So it's not that big of a deal. So you're going to have an interval that you need to know how to label each interval, like as an inequality. Then you're going to have to select a test number. So what number do you want to choose in that interval to test? Remember, we don't want to actually choose the root itself. And then I'm going to put each of my factors. Now, there are 3 factors, so I'm going to have 3 columns. Please go in the order that I'm going on the ones that we do together. Let's do x minus 3 first, because that's the way it goes. X plus 4 squared next. That squared is important. You have to get any exponent that is on there. And then x plus 7. And then the last column is really where our answers are going to be. This is your final product. And what do we want our final product to be? Negative, because that's where my arrow is reminding me. My final product is negative. So if I get a negative as my final, that's where my answers are. Okay? I'm going to draw more. Doesn't have to be perfect. Look at mine, goodness gracious. Can't draw a straight line to save my life. But that's okay. Here we go. Okay? All right. The first interval, A. How do I write that interval?
X is less than -7.
Now, because I don't have an equal to on my original problem, I won't have equal tos on any of these. That's why I got the open circles. So x is less than -7. B.
X is greater than -7.
And
Then negative.
so you do the compound one. Do like that. Okay? So if you're going between 2, just put left, less than or equal to x, less than or equal to right. So this one's going to be like that again. -4, less than x, less than 3. And the last one, you with me?
X is greater than
We've been learning while you've been talking, so we can figure it out.
I know, I was kidding, sorry.
Okay? Now, when you're picking your numbers, remember, we don't want to actually pick what the root itself. Let's just pick a number next to that. So, -7. X is less than -7. Let's choose -8. Between -7 and -4.
-6.
-6.
0.
0,
4.
4. That's what I would do. Just close to it. I would pick whole numbers if possible. The next one, we are going to have to pick a decimal on the next problem. But, like, you're not actually doing the math. You're just finding out is it positive or negative. So it's not bad. Okay? All right, let's do area A first. -8. Now, remember, in polynomial land, it's not just going to be like, oh, it's either in between or it's to the side. You have really no idea because crazy stuff goes on depending on what that power is. So -8 minus 3 is what kind of number?
Negative.
Negative. -8 plus 4 is what kind of number?
Negative.
But what do you have to do?
Square.
Square it. When you square any type of number, what is it going to be?
Positive.
What is this whole column going to be?
Positive.
every single time.
I knew it.
Okay? So be careful with that. Negative 8 plus 7 is a...
Negative.
All right. Think about this. A negative times a positive is a...
Negative.
A negative times a negative is a...
Positive.
So is this part of my answer?
Yeah.
No.
No.
A is out. And give a little X. All right, let's do negative 6. Negative 6 minus 3 is a...
Negative.
We know that's going to be positive because it's squared. Negative 6 plus 7 is a...
Positive.
Negative times a positive is a... Times a positive is a... So is this a part of my answer?
Yes.
Okay, I'm going to highlight that.
Negative.
Okay, then keep filling out the chart. Shh, we don't have to talk. We don't have to talk while we do this. Keep filling out the chart. You can check it with mine. If it helps you to put a little equals right there, so you kind of know you're doing a product between. There you go. So this is how you show your work for me. Okay, this isn't really a part of your answer, but this is how you show your work. So there are two places. Now, no, there could be one interval that works. There could be 2 intervals. There could be 3. There could be 4. There could be none. Okay? Because it totally depends on what's going on here. In our case, there's 2. So on the number line, we need to go draw those in. So B worked here to here. C worked here to here. But because of that open circle right there at negative 4, I have to stop. So when I list my solution set, I have to write both of these. Negative 7. Because it doesn't contain the negative 4, yes. Or, and when you've got multiple intervals, you separate it by or. Negative 4, less than x, less than 3. And that's my answer there. Okay? If you did do I need to write the interval notation?
Oh, you have to write or?
Yeah. Does anybody use interval notation?
Or.
It's on the key on Canvas, so it's there. Because 4 has an open circle. You have to stop there.
Can't equal 4.
Because we don't want to equal 0. We just want to be negative, not equal to 0.
Yep.
Now, graphically, let me show you what's going on graphically here. So I can put, if you want to check, I can put this whole thing in there like this. Again, polynomial graphs, we don't study in this class, so you're not really going to know why this is happening, but this is what it looks like, okay? It's kind of like a big W. So I've got, let me see if I can just squeeze the graph in here. It goes kind of like this. I cross through here, I come up, touch the x-axis, cross through here again. Again, I can't see the lower parts on my graph, but you get enough of an idea to see that, hey, I'm going to be negative from this x value to this x value, and then I still stay negative until the next one, okay? The reason why you kind of have that little archy shape right there is because what's the exponent on the 4? Squared. That exponent is called the multiplicity of that factor. Is making that root behave a little bit differently. That's a pre-cal thing, but that's why that's happening. Yes?
Do you have to write in like the graph?
This graph?
Yeah.
No. I'm just showing you. What I'm looking for here, that's a good question. Here's what I'm looking for. Roots. Now, if it involves factoring, I'm looking for that. This one doesn't. Chart is your work. Number line, intervals that work. 4 parts. Yeah. See? Because a negative times a positive is a negative. A negative times a positive is a negative. Yeah.
What do we do if we don't have this?
Let's look at 4. It says to solve. Okay. All right, look here again.
What's the flip?
This is a polynomial of degree what?
3.
3. And we want it to be less than or equal to 0. So we're already like, quote, less than or equal to 0. But we're given this statement, y'all. Whenever, just like on that CFU, whenever you are given that something is a factor or something is a root, that is code for telling you to do what? Divide. So we need to divide by x minus 1. Now, we don't know the roots to this, and the only way to get it is to factor it and then find the roots, just like on the CFU. But we're going to have to start by dividing. But here's what I want to kind of put right here is I want to be able to write this in factored form. Well, what do I know one of my factors is?
1. Oh, yeah.
Okay? Which means, what's one of my roots?
1.
X equals 1. I know that just from the problem. Okay? But then I need to do division. I need to figure out what the other factors and what the other roots are. Yes, you can do synthetic. Why can you do synthetic?
That's 1.
Exponent is 1, coefficient is 1. So what goes on the outside?
1.
The root. Do I need a placeholder?
No.
So 1, 4, 1, negative 6. Because this is a root, what should my remainder be?
0.
So use that kind of as a checkpoint. 1 times 1 is? 4 plus 1 is? 5 times 1 is? 5 plus 1 is? 6 times 1 is? Negative 6 plus 6? Hey, if you want to talk and socialize or talk or work ahead or whatever, don't. Be quiet. Let me teach how to do it. If you don't want to listen, don't listen. Figure it out on your own. Test. Good luck. But quit distracting those that care. So the quotient is also a factor, but I need you to keep factoring that. So x squared plus 5x plus 6. It's easy factoring. Warning, your test will have not easy factoring on it. Every once in a while. It's on the review. Make sure you practice that. It was in the notes last class. It was the last problem that we did. But this is easy. How do you factor x squared plus 5x plus 6? Try again. That's what I did earlier.
X plus 2, X plus 3.
Plus 2 plus
6
3.
and 1?
No.
Oh.
It's x plus 2, x plus 3. I messed it up last class too, so it's fine. It happens. But it is. It's x plus 2, x plus 3. So I went over here and I want to write this polynomial, the whole thing. The factor that they told me, the factors of the quotient, and then what symbol do I have?
Greater than or equal.
Less than or equal to 0. So I'm looking for what types of numbers?
Positive.
Negative.
And my circles will be closed. So what are my other roots?
Negative 2, negative
3 and negative 3 and 2.
Very good. Okay, put those on the number line here. So I'm going to draw my solutions at the end in this space, just FYI, because my table is going to take up the rest of it. The space for your solutions is on their tests. I'm going to count by 0.5s again on this number line because they are really close. So positive 1, positive 2.
You don't count by 0.5?
No, that's fine. That's fine. I'm just going to try to give myself a little more space. And I'm going to put closed circles. Closed. Closed. And closed because there are 3 roots. There are 4 areas, which does make this a little bit more inconvenient. I'm going to draw again my number line. My chart. My factors are all of an exponent of 1, so I don't have anything like weird going on with that. which is nice. Then I have my final product. Yeah, there's a decimal, but you don't have to actually do the math with it. You just have to, you just have to figure out if it's positive or negative. So it does make it just a little bit easier. Okay? So try this one. All right, here is the sign chart and the solutions for this one. Again, I've got the graph on here, so you can kind of see graphically what's going on. You want to know where you're less than or equal to 0. So that's this guy. This is like A. Then it goes a little bit above for a minute for B. This is C. And then D is above there. So you can kind of check and see, like, okay, that makes sense with what I got on my thing, on my graph. You may have to use a decimal. That's okay. You're just really looking at is the number positive or negative. And then you can get your answer from there. I'm not going to work out all the way with you, example 5, but I will say, what's the first thing that you have to do on example 5?
Move the stuff.
Move the stuff, okay?
Yep.
Then you're given that -1 is a root. Remember, that's telling you to divide.
Oh my god.
So you have to divide and keep factoring. Yeah. It tells you a factor, yes. Yes.
It'd be
X plus 1. Yeah. This is what it looks like. Guys, we're not done. Stop. Do you have a question?
Will we ever see placeholders on this with the X?
You could. I don't. Just put a 0 in. The same way you would. It would. Anything you could. Just roll with it. How do you factor x squared minus 25? It's on the screen, but what is that called? Right, difference of squares. That happens on that one, which is kind of cool. And then you go from there. Okay, let me help you real quick. This is your homework. These 4 problems. Okay? I'm about to make your life a little bit easier. Oops. Let's look at 2 real quick. You will obviously need more paper. You can put this with your other problems that you've been doing because it's still with that. But let's talk about 2. First thing, what's wrong with it? It's negative, but what do I have to do very first thing with the 9x? Okay. Let's do that first. Now, this is saying to do stuff algebraically. So I'm going to want to factor. Do I ever like to factor with a -1 in the front? No. So what can I do? Or divide it because I did a division bar. But yes, it will do the same thing. But what's going to happen to my inequality?
It flips.
It's going to flip. So everything is going to flip, including this. So after you do that, you may want to X out the original and you're focused just with this less than. This is a 3. My bad. How do you factor x to the third plus 6x squared plus 9x? They didn't give me any root. What's the first thing every single time you factor? The very first thing every single time you factor.
Oh,
GCF. What's your GCF here?
X. Do we do anything with that X?
Yes. Y'all, if x is a factor, then what does that mean about your roots? What is a root?
The root.
0 is a root. So because of this x, 0 is a root. How do you factor x squared plus 6x plus 9? 2 numbers that multiply to be positive 9 and add to be 6.
Good job, kiddo.
Very good. So it looks like this. So what's your other root?
3.
-3.
-3. But when you put that into your little sign chart, it's squared. So that's always going to be positive. There's only 2 roots though, so it's less checking for you. Okay? 1 and 2, there's not too much checking. 3 and 4, there's more. There, it's a 4 by 4 or a 4 by whatever table. But then this should only be an ABC. Okay? So, those 4 problems, again, I've got the answers only with me, both notations and number lines. I've got the work that I also have with me as well. But what am I doing when I come up quickly on Wednesday?
Checking homework.
Checking homework. Which homework? 6.3, 6.4, unless you're behind. If you don't have it done when I'm in here, what does that mean? Academic lunch. I want it done. So that way you can spend class time checking it, and then you can also spend your class time working your review and getting that done as well. Okay? All right, that's all I got.
The